Hey guys, it's Janae here. I'm about to, go into an interview. Pretty nervous. Been stressy in a minute. I don't know if Fruit Loops is it a while loop, for loop. Anyway, so wish me luck. I'm about to go into an interview for programming analyst job. Hopefully I do well.
Janae, what is a program performance analysis?
A program performance analysis. Before I tell you what that is, I feel like I need to explain to you what a program is. A program is an expression of an algorithm that you have, and you can do it in different languages. You can do it in Java, you can do it in C, Python, Haskell, which nobody uses anymore. But a program performance analysis itself is basically testing the effectiveness of that program, saying how correct it is, how well it's running. And you want to do that through usability testing and things of that sort. How you go about doing performance testing for a program is you give it test cases. You want to test the boundaries and the parameter of that program. You want to make sure that it's not just working right in this one case, that that you're covering all your bases, and that there's no bugs or loops in your program that would give you a different outcome than the one you wanted. So different ways that I go about it is I'm first might write my my ideas out of what the problem statement is of that, and then I write my code in pseudocode, and I step through it with a flow chart, and you know what the preconditions and post conditions of each step should be, and then that gives me an idea of what test cases I might want to make to test those conditions in different states of my program to see how they react, and what the expected results will be and what the actual results are. And then once I run my program, I see, hey, these are the inputs I put into it, and these are the outputs I got, and how do they match up to each other. And I feel it's really useful when you're trying to get your program to be perfect, to work in every aspect um, that it's supposed to. You want your program to not just work sometimes, you want it to work all the times. And you can't mistake proof your program as much as you want to, but with these kind of tests, you become more confident in your programming, and how well it will stack up to the rest, because you know that you tested this case and this parameter, and you tested it in this environment, that it's still going to work in this. So these are the parameters for my program, and this is how well. So I made it through the first round of the interviews, feeling pretty confident. Not too sure how it's going, but the competition is getting tough. So we'll see how we do in the next round. My program will do in this state.
So, Janae, this is the next question. What is algorithm performance analysis, and how do you do it, and when is it useful?
Okay. Well, an algorithm is a step-by-step procedure, a method of how you want to solve a problem. When you talk about algorithms, everybody has their own, or there's different ways to go through that step-by-step process. A algorithm performance analysis is basically evaluating how efficient that algorithm is. So if we're talking about a sorting algorithm, you want to see how well is that algorithm performing time and time again. So you're gonna look at its algorithmic. You're gonna look at its algorithmic complexity. The big O notation: is it n? Is it n log n? Is it n squared? You're going to want to look at, is it its stability, is it a stable algorithm, or is it non-stable. When you're talking about a sorting algorithm, basically you want to know what is the main operation of it. Yes, you want it to sort the list, or the array that you have, but how is it going about doing that, and what are its special characteristics or properties, and how inefficient how efficient is it in completing those tasks.
When is this useful?
This is useful when you have a certain problem that you need to solve. On the job, you might ask me to sort a file that is of a large size, and knowing the different characteristics and how each sorting algorithm performs, I'll be able to tell you which one is the best. Say for instance, the selection sort, even though it's more it has less exchanges, it's the better one because of that reason. Even though it doesn't have the best complexity rate, because you're thinking about its worst case, best case, and average case, um, when it comes to the user time.
That's good, Janae. Now, can you say what are the differences between these two types of analysis?
The differences between these two types of analysis really are that one is really focused on how efficient it is, the algorithm is itself. How long does it take the algorithm to, from start to finish, get there, and the way it gets there, per se, while the other is focused on the actual accuracy and the correctness of the not the way it gets there, but its output. So in the end, one really focused on effectiveness, while the other is really focused on efficiency. So if I had a sorting algorithm, I would be testing it differently. If I was doing the performance testing, I would, I'd probably put a blank, empty element in there. I might put duplicate elements in there to see the different test cases to see if that changes the outcome, if I actually get a sorted list or not. Whereas if I was just testing the bubble sort itself, per se, I would just be testing, well, in its best case, if I have already a fairly sorted list, what is its complexity rating there, or worst case, if the list, how is the list, is the program adaptive, is it non-adaptive? I would take those into consideration. So those are how I would explain the two differences between the two analyses.